into two projects. In this video, we are going to explain about the project that is SECNN, Squeeze and Excitation Convolutional Neural Network for Sentence Classification. So before getting into the execution, first let us understand what is this project about. Sentence classification. Basically, it is all about figuring out what category or a label a sentence belongs to. This is really important in natural language processing because it is used in things like understanding if a review is positive or negative, labeling topics, and also answering questions or even understanding logical relationship between sentences. Now, one of the popular ways to do this is by using convolutional neural network, or we call them as CNNs. You might have heard of CNNs mostly in image processing, but they work well with the text too. The reason is that they can pick up small patterns of the words like groups of two or three words together, which we call as n-grams. These patterns help the model in understanding the structure and also meaning of the sentence. The great thing about CNNs is that they can do really efficiently. They don't need as many as parameters as some other models and they train faster, which makes them a good choice for handling large amount of text. Although CNNs are really good at looking at words that are close together in a sentence, they have a bit of problem also. They are not so great at understanding connections between words that are far apart in the sentence, even though those distant relationships can be really important for figuring out the meaning. So, to fix this, people started using something called attention mechanisms. Attention basically helps the model look at the whole sentence and focus on important parts, not just the nearby words. But here the thing is, the most of the existing methods with attention only look at individual words or features. They don't really consider the bigger picture, like how the different parts of CNN's feature maps themselves might be contributing to understanding the sentence. That's a limitation researchers are trying to overcome. So, in this project, we are introducing a new system called SECNN, which stands for Squeeze and Excitation Convolutional Neural Network. The main idea is that unlike regular CNNs that mostly focus on individual words or features, this model looks at the channels of the CNN feature maps and figures out which one are more important. This helps the model to learn better representations of the sentences. Here is how it works. So first, every word in the sentence is converted into a dense vector using either pre-trained embedding words like word2vec and the globe, and also embedding that are learned during training. And then comes CNN blocks. So next step is that these vectors go through multiple parallel CNN layers, which extract n-gram features, basically patterns of the words in the sentences. Each CNN generates a set of feature maps, and in SECNN, each feature map is selected as a separate channel. So first we will be doing vectors using these models that are pre-trained vectors, word2vec and glow, and then we will be training with the CNN model. Then comes the special part, squeeze and excitation block, or we call as SE block. These blocks look at all the channels and assign weights to them, basically deciding which channel is more important and which is less. They use techniques like global average pooling and some transformations to calculate these weights, and then we will be scaling the feature maps accordingly. This step helps the network focus on the most informative parts. Finally, feature maps, that is the recalibrated feature maps, go through max pooling and dropout for regularization. And then a fully connected layer that predicts the sentence label using a sigmoid or softmax function. So overall, SECNN doesn't just look at words individually, it looks at the bigger picture of the feature channels and how they relate to each other. This makes the model more robust and context aware when classifying sentences. And as an extension to this project, here we are integrating more advanced models. So first, we have upgraded using Electra, which is more powerful model for representing sentences. This helps the system understand sentences more accurately and improving the classification results across all the datasets. Then comes using explainability models. So we wanted to make the system more interpretable. We integrated LIME, which is an explainable AI technique. LIME helps us to show which parts of the input text were most important for model's predictions, so that we can understand why the model made a certain decision. Then we have developed a web-based interface using Flash framework for the user authentication. This allows users to input their own text and get predictions from the trained model directly, making the system user-friendly and accessible. Finally, we have also included topic modeling using latent dirichlet allocation, which helps to analyze the data sets and extract the main topics. This provides additional insights into the data and helps to understand the underlying patterns in the text. So these are the techniques that are incorporated. Now, to implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented. First, we have imported all the necessary libraries that are Python libraries that we need for data processing, modeling, and visualization. Then comes data ingestion. So next we will be collecting data sets IMDb, AG News, and DBpedia from Kaggle and load them into Pandas data frame. This allows us to easily manipulate and process the data. Then comes data processing. Here, once the data is loaded, we clean it. We normalize the text by converting everything to lowercase, remove HTML tags, URLs, and any non-printable characters. We also handle punctuation depending on what the model requires and encode the labels so the system can understand them for classification. Then comes embedding. In this step, after cleaning, we will be converting the sentences into numerical representations using embedding like glow, word2vec, and BERT. These embeddings helps the model to understand semantic meaning of the words and sentences. Then comes data visualization. So here in this step, before building the model, we explore the data visually. We create charts to see the distribution of the sentiment types or topics, and we generate word clouds to identify frequently occurring words in the dataset. Then comes feature extraction. Here we will be extracting important features from the text that will serve as input for the models. This helps the model to focus on the meaningful information. Then comes data splitting. Here we will be splitting the data sets into two parts, that is training and testing. The training set is used to teach the model while testing set is used to evaluate the performance. Then comes model building. Here in this step, we will be building and also training various models, including baseline models like CNN, CLSTM, ATCNN, BERT, and our proposed model SECNN, as well as the extension model, Electra-based model. Then comes model evaluation. Here in the step after training, we will be evaluating the model on the test set using metrics called accuracy, precision, recall, and FN score. And we also use confusion matrix to see where the model makes mistakes and also apply explainable AI techniques like LIME to understand which features influence the predictions. And we will be saving best performing model for the future use. Then comes the front end part. So we will be deploying the system as a web application using Flask. So users can enter or upload text, the pre-trained model, process it and performs pre-processing and embedding, predicts the sentence class and even performing topic modeling to extract key topics. The results, including class labels and confidence scores, are displayed interactively on the web page. So this is how we have implemented. Now moving on to the algorithms used. So these are the algorithms used in this project. And to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So let's open it. These are the source code files of this project. So let's understand each of them. How will they be used in this project? In this folder, we have the dataset used. Here we have four different datasets. We have used AG News, DBpedia, IMDb, and MR dataset, that is movie review dataset. And here we have Glove model. Here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. Here we have static folder in which we have CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. So this templates folder, it contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases folder in which we have test cases that we will be using in the front end. And here we have AG News notebook file. Here we have multiple notebook files. So these are all the notebook files, which are Jupyter notebook files. These contain a combination of code, graphs, and outputs all in one place, and it allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is database file, which is used to store the user information. This is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I've copied it. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. So this command, it will execute Python script and perform a runtime check for any syntax issues, that is any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So just wait for a while, file is being compiled. So this is the address where application has been hosted. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. So open Chrome, paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get registered first. Click on register and enter all the details and create an account. I have already created, so I'll directly sign in. Click on sign in and give your username and the password. Now click on sign in. We have signed in successfully and redirected to prediction page of this project. So here you can see a text box, right? In this, we are supposed to give the input and select the model configuration of the selected data set, and it will calculate the text length, and we need to click on analyze data set. So let's enter. For that, let's open the test cases. Let's try with this test case. And now, so here we have total 4 different classes. So let's copy the first one. We are trying with the class label 0. Paste the text and select the model configuration, that is AG News, and now click on Analyze Text. So here given input will be pre-processed at the backend. It will be fed to the trained model, and then trained model will be giving us the prediction. So just wait for a while. Here we got the prediction that it is world. It belongs to the world group, where confidence is 99.3, and here we have model type, text length, processing, confidence analysis, where it is high confidence. Here we have analysis time, which took very less time, algorithm which is using, status, and topic analysis, which are the key terms of this text. Now let's check with class 1. So apply filter to it. Now click on analyze new text. Let's select this one, paste it, and let's apply filter to this one. Click on analyze. Here you have 255 characters. And here it belongs to sports group. So this text is of sports classified. And confidence level is 99.76. And this is the model information. Here we have confidence analysis as well as processing details and topic analysis. Let's check with the other one. So click on analyze text. Now let's apply filter to class 2. Click on OK. Copy any random text and paste it here. You can also generate text by click on load in sample. So if you click on this load sample, we can generate text. Select AG News. Now click on analyze text. And here we got the prediction that it belongs to business group. And this is the confidence level. And here we have model information, confidence analysis, processing details, and topic analysis. Now click on analyze new text. Let's try with class 3. Click on OK. And let's copy this one, paste it. Select model configuration as AG News. Now click on analyze text. And here we got the prediction that it is SkyTech. It belongs to SkyTech group. And here we got the prediction 99.66, which is high confidence. And here we have topic analysis. Now let's try with the analyzing new text. Let's open the other data set. Let's try with this one. Yeah. So here we need to give the input text. Let's apply filter to label folder, label column. And here we have total 14 types of labels. So let's apply filter to class 0, copy the text, paste it. So the model configuration is dbpedia. So click on analyze text. And here we got the prediction that it is company group. So the classification is our company and 99.69 is the confidence level. And here we have all the analysis graphs. Now click on analyze new text. Let's try with class 1. Click on OK. Let's randomly give this one, paste it, click on analyze new text. Until then, let's apply filter to the other class. Let's apply filter to class 2. And here we got the prediction that it is educational institution text it is. And conference is 99.86. Here we have model information, confidence analysis, processing details, topic analysis also. And here we have topic identifier as, that is topic identifier as 1. Now let's analyze new text. Click on that. Let's copy this one. So paste the text here. Click on analyze text. Here we got the prediction that it is artist. And this is the confidence level. Let's try with the other one. Click on analyze. And let's check with class 3. Click on OK and copy the text, paste it, analyze it. And here we have prediction as athlete, which confidence score is 99.96. And here we have model information. Here we have confidence analysis, processing details, and here we have topic analysis where topic identifier is 0. Let's try with the other one. So let's apply filter to class 4 and click on OK. Copy the text, paste it, click on analyze text. And here you have 446 characters. Here we got the prediction. So we got prediction as 99.93 and here we have office holder. Prediction as office holder and this is the model information which is model type is dbpedia with the 447 text length. Processing is completed and here we have high confidence and here we have topic analysis. Here we have keywords, key terms, topic identifier. And here you can even print the results and also download the report. Now let's try with the other case. So let's try with class 5, apply filter to it, click on OK. And now copy this one, paste it. Click on analyze text. And here we got the prediction as means of transportation. It is mean of transportation and this is the confidence level. And here we have model information, configure that is confidence analysis, processing details. Let's try with one more, click on analyze text. Now let's try, let's generally load the samples. So let's click on load sample. Here you can observe some random text has been generated. Now click on analyze it. And here you got prediction to be as company with the 69.98 confidence level, which is medium confidence it is. Let's try with the other text. From the test cases, click on analyze new text. Let's apply filter to class 6. Click on OK, copy it and paste it. Click on analyze text. So here you can see building has been predicted with the confidence of 99.89. Now let's try with the other class. So let's apply filter to class 7 and click on analyze new text. And here we have text box. Copy it, paste it. Click on analyze text. And here you got the prediction as natural place and this is the confidence level. In this way you can try with the all other cases also. Now click on OK. And here you have topic analysis. Now let's check with the other data set. So click on analyze new text. Select the model to be IMDb. Open that test cases. And let's apply filter to sentiment class. Apply filter. Now apply filter to negative. Click on OK. So copy the text, paste it, click on analyze. Here you have 935 characters. Here we got the prediction as it is negative sentiment with the 99.95 confidence level, and the model type is IMDb. Text length is 936 characters. Processing is completed. Here we have high confidence, that is 99.95. Analysis time is 2.3 seconds. And here we have topic analysis. Let's check with the other one. Click on analyze new text. And let's load sample. Select IMDb. Click on analyze. And here you have positive sentiment. So based on the given text, here it is predicting it as positive sentiment with the confidence level. So let's apply filter to sentiment positive here. Click on OK. Copy any text. Click on analyze text. Paste it. Click on select IMDb. Click on analyze new text. And here we got the prediction that it has positive with the confidence of 99.96 confidence level. And here you have model information, confidence analysis, processing details, and topic analysis, where topic identifier is 0, which represents the main semantic category of your text content. And here we have key terms. We can even print and download all the reports that we have generated up till now. Now let's check with the graphs. Click on graph. Under graph, let's see with the DBpedia. So here we have graphs of DBpedia. This is the label distribution. Here on x-axis, we have all the classes that we are predicting, and on y-axis, we have count. Now close it. And here we have text length distribution. So here on x-axis, we have number of words, and on y-axis, we have frequency. Here we have word cloud. Close it. And here we have confusion matrix. Close it. This is the accuracy comparison graph. And this is the precision comparison graph. And here we have recall and FN score. Similarly, let's check with the graphs of AG News. Here we have AGS label distribution, length distribution, word cloud, and confusion matrix, accuracy score, precision score. Similarly, we have other two graphs also. Let's check with IMDb. So click on that. Here we have IMDb label distribution, length distribution, word cloud, confusion matrix, accuracy, and the other performance scores also. Now click on logout. So this project makes it easy for computers to understand the meaning of the sentences, classify them correctly, and show important insights, all in a way that anyone can use. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.